about something like this? A couple of ways I can look at this one. Technically, using properties of exponents, what would I do if I have a product to a power? What could I do to the exponent? I could distribute it, right? I could write this as like 6 cubed times 5 cubed. And then I'm just going to have to turn that into a big number, 216, and that a big number, 125, and then I'm just going to get a big number from that product, right? That's one option, and that's fine. It's going to give me some big number. What else could I do? Because these are numbers, if I were to follow order of operations strictly, first thing it says is P, right, for parentheses. Can I simplify what's inside the parentheses? I can. What's 6 times 5? 30. So in this case, I really could just write this as the number 30 cubed, which is actually easier to deal with, right? That's going to be, what, 27,000, right? So, and I can get that pretty easily because I've got 3 zeros, right, when I cube 10, and then 3 cubed is 27. Okay. Does that make sense? So with the numbers, a lot of times I can do stuff in the parentheses to sort of simplify what I'm going to be, the number that's going to be the base of the exponents. Okay? Either way will work. I'm just going to zip through a couple of these. This one's, real quick, what's the answer to this? And why? I've got 7 to the negative 4. What's that negative exponent do again? Negative exponent on top is what? Positive where? On the bottom. So this becomes 1 over 7 to the 4th. So it's just going to be 1 over some big number, right? Okay. Okay, what do I do, just to warm up kind of here, what do I do if I divide like bases? Subtract exponents, right? But we want to write this as a simplified answer. We don't want to have any negative exponents in our answer, right? So we're going to use the little trick that I showed you last week, right? When we divide like bases, we always want to keep the base where it has the most power, right? So where does this one have the most power? On the bottom, right? So then this is going to become 1 over 2 to what minus what? 3 minus 2, yeah. Because we kept it on the bottom, we're going to subtract 2 from 3. And that's just 1, isn't it? And what's 2 to the 1? No. 2. Right, remember that any number always has an invisible exponent of 1. Yeah, don't confuse this with the 0 exponent property. Any number to the 0 is what? 1. Good. So that's a little different, but that's our answer here, just 1/2. Oops. Okay, we can probably zip through some of these here. What's that one? 1, because it's to the 0, right? Okay, real quick, what's my base here? -3. Okay, so fill in the blanks for me. If we take a power to a power, what? The exponents. Multiply. Good. Power to a power, you multiply the exponents. So in this case, I've got my base of -3 to what power? 6. 3 times 2 is 6. Okay, here's the other thing that I think is really useful. Remember, we talked about earlier in the year, whenever you square a negative number, instead square what? What should you do? Because otherwise there's potential for making a mistake. But what's -8 squared? Positive 64. That's the same as positive 8 squared, right? So whenever you square a negative number, always just square the positive. Because that's a super common mistake that people make, is when they square a negative on a calculator, for example, they don't put it in parentheses because that's a lot of buttons to push. So always just square the positive. Well, what did we say last week? If I take a negative number to an even power, what do we always get back? What sign do we always get? What's that going to be? A negative number to an even power is what? Positive every time. It has to be. A negative number to an odd power is negative every time, right? So if we know we're going to get a positive answer, why not just write this in terms of a positive base, right? Does that make sense? Otherwise, you're just likely, because if I enter this on a calculator as negative 3 to the 6th, it's going to incorrectly give me back a negative answer, right? So always just, if you've got an even power, make the base positive anyway, at least when you're typing it in your calculator, okay? And then that's just a calculator number. There is a little trick here, though. There is a little trick you could do with this. If you want to evaluate 3 to the 6th, and you want to do it quickly and you don't have a calculator, this wasn't the most convenient way to do it. 3 cubed is 27, and 27 squared is who knows, right? But we could break this down a little differently. What if we wrote this as 3 squared cubed? Because 2 times 3 is 6, so that works, doesn't it? That gives us 9 cubed, and 9 cubed is more recognizable. 9 cubed, that's a number I'm going to force you guys to memorize, actually. I'm going to have you remember your perfect cubes through 10, and your perfect squares through 15. And so that's one you're going to know. 9 cubed is 729, so that makes it easier to do. You can do it then without even needing a calculator. Okay? Questions? Okay. Okay, multiply like bases like this. 3 is the base, right? If I multiply like bases, what do I do to the exponents? Add them. Yeah, so this is 3 to what power? 9. Big number. Whatever your calculator tells you that is. 3 to the 9. Okay. And then probably the last one we need to do on here. So what about this? If I take a quotient to a power, what can I do? Distribute. Yeah, so I'm just going to distribute the 4. So this ends up being 8 to the 4th over 5 to the 4th. So I'm just going to get some big number on the top divided by some big number on the bottom. Okay. Top, I don't know. Bottom's going to be 625. Top's going to be something big. So who knows? But your calculator will tell you. And yeah, we'll have to see what it is. Okay, same thing. What's my base? Negative 4. If I, what's the power going to be in this case? If I multiply like bases? 6, good, because I'm going to add them, right? Because you multiply like bases, you add the exponents. So I've got negative 4 to the positive 6. How would I probably want to rewrite that? 4 to the 6th, right? Okay. Okay, so that takes care of that one. Let's look at next assignment. Now this one is easier in a way. It's easier because it deals with primarily exponents, and this is going to sound weird, but properties of exponents with variables is way easier, and you'll see that in just a second. That's simple. What's the answer? H to the 8th, done. You can't simplify it more than that. If it were a number, I'd have to figure out what the number to the 8th was, and it might be some huge number, right? But with a variable, that's it. H to the 8th, and we're done. Okay, what am I going to do there? Simple. Distribute. So my answer is y to the 8th times z to the 8th. Yeah.
So would that be the answer, or would you?
That's the answer. That's as far as you can go. And you see what I'm saying? How the variables are so much easier? There's not much to do, right? Yes, sir. No, you wouldn't need it in parentheses. Okay, this is maybe one that's worth looking at real quick. So what about this now? When we start to deal with a little bit more complicated ones like this that involve numbers and variables both, a good way to approach these is just to take it one piece at a time. So let's start off with just the number. And that's the hardest part. You'll notice this will be the hardest part of this whole problem, is just simplifying the fraction part. So 18 over 21. What's the greatest common factor of 18 and 21? 3. Good. 3 goes into 18 how many times? 6 into 21. 7, and then we can see that that's not going to reduce any further, right? And then we've got like bases. So where's the y going to stay on this one? Vanessa, what do you think? Where's the base going to stay?
Top.
How come? We got y to the 4th on the top and y to the 7th on the bottom.
Bottom.
Bottom, good. So I'm going to get y to what power on the bottom then? If maybe we haven't reviewed this one yet. If I divide like bases, what do I do to the exponents? Subtract, that's right, subtract. So I'm going to keep the y on the bottom, and then I'm going to have 7 minus 4 is 3, right? So that's my answer. Okay? Make sense? Okay? It's simple. That's the answer. What happens to the x if it's to the negative 9? So there's really just two things going on here, right? I've got a number and a variable. Nothing's happening to the number. So on these kinds of problems, just make a fraction bar. Start with a fraction bar. You may end up not needing it, but it's a good place to start. The 7 is on the top, right? What about the x? Where does it go? To the bottom, because a negative exponent on top is a positive exponent on the bottom. So we write it as 7 over x to the 9th. Now notice the instructions always say write it in terms of positive exponents. Okay, so that's our answer. 1 step. Okay? What would we do to this? Distribute 5. Y to the 5th over, or excuse me, W to the 5th over Y to the 5th. No big deal, right? Okay. What's that? Y to the 6th. Power to a power, you multiply the exponents. Y to the 6th. Okay, where's the V end up this time? On the top to what power? 3. Yeah, negative on the bottom is positive on the top, right? And the 11 just stays on the bottom. Okay? Make sense? Okay, where's this one end up? Bottom. Okay. So then I'm going to subtract on the, what's going to be W to what power on the bottom then? It stays on the bottom. 4th, good. What do I put on top? Ah, got to put a 1 there, don't I? Got to hold that place. So I end up with my W to the 4th, which means I have to put a 1 on the top. Okay. Okay, we did one like this. No biggie. Let's get that. I think we're ready to move on. Okay, so now let's look at more than one thing going on at once. So what about this? Stare at that for a second. What am I going to do to this? Yeah, I would. I want to simplify as much as I can. Good. So what can I do inside the parentheses first? Yeah, so I can reduce the fraction for one thing. 30 over 18. What's the greatest common factor of 30 and 18? 6. Good. 6 goes into 18, into, oops, sorry, backwards. 18 3 times into 30, 5. And 5/3 won't reduce anymore. And then there's nothing else here. None of these other variables are in common, so I can't do anything inside the parentheses to simplify any further. But at this point, what would I do? Distribute. Yeah, just going to distribute. So I'm going to end up with, when I distribute that variable to all the parts, I'm going to get 5 cubed on the top. You know what that is? What's 5 times 5? Times 5? 125. and then 3 cubed. That is 27, right? And then all the other ones, I'm just going to be cubed, right? I'm just going to distribute. What's the current, what power is u being taken to inside the parentheses? Yeah, remember, there's always an invisible 1 there, right? So when I take a power to a power, I'm just going to end up with u to the third, right, or u cubed. Z cubed over x cubed, y cubed, and that's my answer. Okay? Okay, it's really pretty simple. The only thing we're doing here is we're just having to move some of those variables to the other part of the fraction to make the exponents positive. So what's my answer going to be? What's going to end up on the top? How about the u to the 8th? Does that go anywhere? No, that stays put. And none of these are like bases, so we can't, we have to do anything there, right? You just have to put them in the correct places. What about the y to the negative 10? Where should that go? On the bottom. Starts on the bottom. Top. And then the x goes to the bottom, right? That's it. Okay, this is no big deal, right? It looks like a lot of stuff, but there's not much going on. Really, we're just multiplying like bases, aren't we? So what about the u's? What's going to be my final power of u? If I'm multiplying u cubed times u to the 5th, what am I going to get? U to the 8th. Multiply like bases, I add the exponents. X to what power? 4th and z 10th. Done. Okay. Okay, what about this guy? Can't do anything inside the parentheses. What can I do to that exponent? Distribute. Yeah, so we'll just distribute the 3 to both bases. So I'm going to get 8 cubed, which is 512, I think, times z to the 7th to the 3rd. What's that? Z to the, I think I heard it, 21st. Because we take a power to a power, we multiply, right? Okay? Okay, what's the answer to that? Quick. 1, how come?
0.
Yeah, anything to the 0 is 1. And then we've done stuff like that, haven't we? Right? We're just going to take care of, all we're going to do here with this one, we're going to take care of the numbers first, right? So 42 over 48, what's the greatest common factor of 42 and 48? 6. 6 goes into 42, into 48, so it reduces to 7/8. Okay, what about the x's? What about the x's? Carolyn, if I've got x to the 10th on the top and x squared on the bottom, what do I end up with? Where does the x have the most power?
On the top.
On the top. So we know the base goes to the top, and then if we divide like bases, we subtract. So what are you going to get? Yeah, good. 10 minus 2 is 8. Perfect. Okay, so where's the y go? What do you think? Manuel, help us out. On the bottom, okay? What power? 3. 7 minus 4. Good. Okay? Perfect. Okay, skip that. Maybe we'll do, real quick, we'll do this one. Okay, we could distribute the negative 2, that'd be fine. That's one thing we could do, is distribute the negative 2. What else could we do with this? if I've got something, just call it hand. If I've got something to the negative 2, what do I do if I have a negative exponent on the top? Move it to the bottom and make it positive, right? So I could rewrite this as 1 over whatever I was taking to the negative 2. That's the whole thing, right? That's 8v squared. And now I can distribute, right? And get 64v squared. Are we done? We're done, aren't we? Wow, these Mondays are so short. Okay. You got your assignments. You know what to do.